Hi, this is the video for lesson 1.2.4, and today we are talking about rotations. So you are going to complete rotations on these problems. So a rotation is a turn, and the first thing we need to talk about is the difference between clockwise. Clockwise is the way a clock goes, so it'd be this way, down to the right. And then counterclockwise would be the opposite of that. So down and to the left, the opposite of how a clock goes. So we're going to talk about, does it matter if you do clockwise or counterclockwise? But we're going to use tracing paper. So you should have gotten this tracing paper in class from your teacher. We're going to use that. So the way we're going to use that is you are going to put, and you might have a bigger piece. I just have a little square here, but you might have a bigger piece and you're just going to need a part of it. So I'm going to use tracing paper to trace this shape. And I'm also going to trace the dot. The dot is important. So here is my original shape. And I'm going to go 180 degrees. So that's half of a circle, right? A full circle is 360 degrees. So 180 is half of a circle. We're going to go clockwise, so the way a clock goes. So remember, a clock goes this way. So I'm going to turn it, kind of thinking of putting your finger there like as the pivot point, the turning point. That would be 90 degrees. This would be 180 degrees. So my rotation of 180 degrees would end up here. So then I'm going to trace what I have. So that's 3 blocks, and then I'm just kind of drawing the shape. So if I take this shape, rotate it 180 degrees clockwise. So now I'm going to take the same shape, and I don't need to trace it again, right? It's the same exact pre-image, right? First shape is pre-image. But now I'm going to go 180 degrees the other way. And when I do that, notice what happens. It looks exactly the same. So I'm going to trace that one out onto the grid paper. And I have this shape. So they look exactly the same, these two answers. This one 180 degrees clockwise, this one 180 degrees counterclockwise. And if you think about it, why would that be? It's because of the 180 degrees. 180 degrees is halfway around. So if you go halfway, exactly halfway, it doesn't matter if you go to the right or to the left first, you end up in the same position. So that was because of 180. Now, on this one, we have a new shape. So I'm going to take a new little piece, or you can just move to a new area if you have a bigger piece of tracing paper. And I'm going to trace this shape onto my tracing paper, and I'm going to trace the dot, and the dot is the pivot point, the turning point. So I'm going to hold that steady with my hand, and I'm going to go 90 degrees clockwise. And when I do that, I get this shape, 90 degrees clockwise. 90 degrees is like a right angle, half of halfway. 180 degrees was halfway, so half of that is a quarter of the way. So this went a quarter turn this way, clockwise. So I'm going to trace that. Draw that onto my grid. So that would be 90 degrees clockwise. Now down here, I am to do 90 degrees the other way. So it's the same shape, 90 degrees this way. So I hold it at the pivot point. Maybe take your pencil to hold it at the pivot point and turn it 90 degrees counterclockwise, the other direction. So watch the turn. So here's the original, 90 degrees counterclockwise, and trace that one onto your paper. So that's that shape. Okay, what's the difference? Here, when I went clockwise versus counterclockwise, I got the same answer because they were 180 halfway. But this was 90. So 90 clockwise and 90 counterclockwise are two different answers. Hopefully that makes sense. The difference between 180 halfway doesn't matter which direction, but 90 matters if it's clockwise or counterclockwise. Now let's look at 270. So this is the same shape, and I'm going 270 clockwise. Well, how many 90s would that be? 90 goes into 270 3 times, right? 9 goes into 27 3 times. So that would be 90, 180, 270. So 270 clockwise is here. So I'm going to draw that on my paper. So 270 clockwise. Well, wait a minute. That looks familiar. Isn't that the same as this? Aren't the end results, the image, the same? So 90 degrees counterclockwise, CCW, is the same as 270 degrees clockwise. Think about it in terms of quarter turns and half turns. This is a quarter turn, and this is 3/4 of a turn, right? 270 is 3/4 of 360. 360 would be all the way around. So hopefully it makes sense if you think of it like that. A quarter turn in one direction is the same as a 3/4 turn in the other direction. What's going to happen with 360? 360 degrees is a circle. So if I take this and rotate it 90, 180, 270, 360, isn't it back to the same thing? Because it's a full circle, right? So I need to trace over this so that I know that the image is over top. The image is over top of the pre-image, right? They're smack on top of each other. It doesn't look changed, but it did do a rotation. It just matched up with itself. Okay, so now let's look at the next one. So I'm getting another piece of tracing paper, and I'm going to trace this N onto my tracing paper. There's my point in the middle, my point of rotation. So I'm going to go 180 degrees. 180 degrees is halfway. It didn't give me a direction. Why? Why would it not give me a direction? 180 degrees is halfway. Does it matter which way I go? Well, we could try it both ways and see. If I go halfway, the N matches up with itself again. What if I would have gone halfway the other way? The N matches up with itself again. So don't leave it blank, because then I think you didn't do any of the rotation. Trace over it so that I know that you know that it looks the same after you rotate it. Okay, one more. A square. If I do a square and I go 90 degrees, again, it didn't give me an answer or a direction. It didn't give me a direction of where I had to go, clockwise or counterclockwise. Why do you think that is? If I go clockwise, 90 degrees, isn't the square still mapped over top of each other? What if I would have started here and gone 90 the other way? Doesn't the square map on top of itself? So it doesn't matter for the direction. Would that have worked for a different degree? What if I would have done 180? It wouldn't have mattered. It would just be upside down, but it would map on top of itself. So the question here says, why aren't directions of rotation given for these two? Because the shape still maps to itself either direction for those degrees. And it's important that you know that, oops, that's not on the camera, because the shape still maps to itself either direction for those degrees, 90 and 180. If I would have done 45 degrees on the square, right? That's not going to work. What if I would have done like 60 degrees? It does not match up with itself. Only 90 here and 180 here. 90 and 180 and 270 would actually all work here. And we're going to learn more about that later in the chapter. A little foreshadowing. Okay, so let's try this in a coordinate plane. If a figure is rotated, how can you describe it? So we're going to graph 4, 1, and B is 2, 5. We're going to use tracing paper to rotate about the point 0, 0. So I've graphed my point A, B, and I'm going to connect them to make a segment. And then I'm going to use tracing paper. So here's B, and there's A. And I'm going to go 90 degrees counterclockwise. And I draw a little X, like a little plus sign here at the origin. I don't know if you can see that. I draw a little plus sign here at the origin so that when I rotate it, I can make sure that it matches up exactly. Like I'm not slipping, right? Because it'd be easy to slip your hand here and mess up the points, but you want this plus to be right at the origin because that was your center of rotation, your turning point. So this rotates 90 degrees clockwise and I get this point. So that is, you trace it, A and B. A prime and B prime are my new points. So what are the new points? A prime is the point -1, 4. And B prime is the point -5, 2. And we're going to look more at these relationships in class next week. But there is a relationship between the numbers here and these numbers. Now, did the size of the segment change? Same length, matches up perfectly on both. So then we say that that is an isometry because what does isometry mean? It means size and shape do not change.